Okay, so this video is going to go over real life algebra number 2, 7, and 10. So again, if you have not done those, please do those first before you watch this video. In this packet of notes, I did not include the real life algebra handout again because I know I had put it in two of the other video packets, plus it is also in the the algebra module on Canvas. So again, remember, it looks like that. Also, the third page of the handout notes for this video, there are 9 just review miscellaneous problems. So to get the most out of this video, when we get there, you can pause it, try these 9 problems first before you watch me do them, or also before you look at the answer key. All right, real life algebra. Oh yes, number 7. And that's why I had stats on my mind, because this is one that pulls the empirical rule from our statistics part. So let's see. Weight of trout is believed to be normally distributed. Remember, we needed normality, unimodal, and symmetric when we did the empirical rule. A group of biologists survey fishermen, and they see that 2.5% over 9 pounds, 16% are below 1 pound. Those percentages should be jumping out at you from the empirical rule. So let's draw. And then it asks you what's the mean and standard deviation. All right, 1, 2, 3, 1, 2, 3. Little review of the empirical rule for the final exam. That's not going to be that far from now. All right, 2.5 weigh above 9 pounds. So this is the 9 pound mark. And then 16% weigh below 1 pound. So this must be the 1 pound mark. And 16% are below it. And yes, they're asking for the mean and the standard deviation. We're going to approach this from an algebraic standpoint. There is a shorter way to do this problem from actually statistics, but I'm just using this as a setup to make you practice solving a system of equations. So this is a z-score of 2. This guy is a z-score of -1. That's just going back to our stats stuff, right? So z-score equals x, the x is the 1, minus mu over sigma. That's all I have there, right? We did things like this, although we never had 2 unknowns when we were doing the empirical rule. Z equals the x is the 9 minus mu over sigma. But that's okay that I have 2 unknowns because I have 2 equations. Now, to be honest with you, my handwriting on mu's and sigmas are going to start to look kind of funny, so I was going to just change it back to x's and y's. And then you could imagine that maybe this was a system of equations listed in your book or an algebra book. Now, granted, usually they don't look this ugly in an Algebra 1 textbook, but all it takes is one step to make this not look ugly, to make it look like something you would see in an Algebra 1 textbook. Excuse me. We don't like fractions, right? Multiply both sides by y. Multiply both sides by y. I'm just going to write it below. That looks like something you absolutely would see in an Algebra 1 textbook. Again, there are you could do, as I solve these, I solve them originally, then I solve them when I'm prepping your notes, and now I solve them in front of you. Every time I see a different way I could solve it. There are so many ways. So again, on the notes that go with this, I used a substitution method. So you can look at that. But as I'm sitting here, and since I wrote them over top of each other, this actually is begging me for the elimination method. Look, minus x minus x, everything would fall away. So this is an example where I'm going to subtract, because minus 1 minus minus would be plus 1. My x's are going to go away. Minus y minus 2y minus 3y. 1 minus 9 minus x, basically then plus x, that goes away. Y is 8/3. And then you can stick that in wherever you want, and you'll get x is 11/3. So here's one way of doing it. You can look at my answer key for another way, and there's probably still 4 more ways after that. As long as you are getting these 2 answers, that's what's most important. All right. Number 10 on real life algebra is a very quick one. It's just very real life. We often hear about the stock market crashing, whether it was 15 years ago or now, unfortunately, currently. Stock market always does rebound, but let's just make sure that it's not quite as simple as what some people would like to believe. I invest $1,000 into the stock market. A fast mini crash occurs and I lose 40%. Well, let's go ahead and figure out how much money you have. You had 1,000 and you lost 40% of the 1,000, right? So 1,000 minus 400, you now have $600. I feel like the market will rebound, and it does. Actually, the very next month, it gained 40%. A lot of the general public thinks that they would be back to where they started, and that is not how it works. Now we're going to gain 40%, right? 600 plus 240, I am back to 840. Definitely not the 1,000 that I started with. So unfortunately, it doesn't work like that. All right, let's go to Busch Gardens with my family. Number 2. This was extremely real life. We are only going to do this problem up through the twice part. I think towards the end it starts talking about 3 times. But we're only going to do it up. I think the original answer key might actually have it for 3 times if you wanted to keep going. But anyway, number 2. So, particularly when my kids were young, and I did have 4 of them, and they would see the advertisements, how you can buy, like a yearly pass to Busch Gardens. We did something called the Virginia Fun Card since we were a resident of Virginia. And they always used to try to say, well, Mom, after the first time, it's pretty much free. And what kids don't understand is going to Busch Gardens is so much more than the actual ticket to get in the gate, right? Busch Gardens makes money off of all the other things. Parking and food and games. That's where they're making a lot of their money. Also, to drive my 4 kids to Busch Gardens, I absolutely would always take my conversion van because there was a lot of room for them to spread out because it would take us almost 3 hours to get there. Then on the way home, they had room to fall asleep. We were not going in my Corolla. That would have been miserable. So it's all part of my real life problem. So there were 5 of us. Tickets at the time, I'm sure there are more now, but tickets at the time were $65 each. I would always drive my big conversion van. I'm lucky if it gets 15 miles per gallon. It is a total, it's 160 miles one way, so total of 320 miles to get us there and to get us back home. And gas prices were kind of high. Per gallon. Were kind of high back then, but you can always knock that down if you want to make it realistic. The other thing that is much more expensive now. At the time, parking was $13. I'm pretty sure parking is now $20. And just want to show you how, because I was very thrifty because I had a lot of kids, right? I am making these numbers pretty small. When the kids were little, I would bring all the peanut butter sandwiches and the Skittles and the snacks. I would also bring a lot of water bottles where I had frozen half of the water bottle. Then I'd put fresh water on the other half to try to help them stay cold throughout half the day. I would bring in as many water bottles in a book bag on my back as I could. And with all of that, that's how maybe I was able to escape only spending $80 for all of us total for a day at Busch Gardens. That's not a very fun day with me, right? That probably did not include ice cream and funnel cakes and all of that. If you've been to Busch Gardens, you know one meal plus a drink for one person can easily be $15. And if you're staying there all day, you're gonna need to eat more than once. So that's a pretty low number, but we're gonna use that number because that was pretty realistic. All right. It kind of talks you through that if we go to Busch Gardens twice this year, how much does each visit basically cost, and then also how much per person. First, let's wrap our minds around my van, the gas, right? Now, I think at this point we've done this 20 times. I have to go 320 miles. My van gets 15 miles per 1 gallon, and the price was $3.75 per gallon. So what is it taking me? I'm cheating. Oh, yeah. $80 in gas just to drive my kids comfortably to Busch Gardens and drive back home. Okay. So let's say we're going to go twice. All right. 2 times parking plus 2 times food plus 2 times gas plus, well, the tickets I only had to purchase one time, right? So that's only going to be a one-time thing. So 2 times 13 plus 2 times food is 80. Gas coincidentally turned out to be 80. Plus, I had to buy 5 of those tickets, right? Don't forget there were 5 of us going. That gives us $671 total just to go twice. See, 5. My kids were like, okay, spend the $325 on the tickets, Mom, and then basically everything else is free. No, it's not. I'm already up to $671 for 2 full trips. So $671 divided by 2 is $335.50 per trip. You could divide that by 5 to get it per person. 5. That's actually more expensive than the original tickets. So you can imagine if we went 3 times, which is usually when you start to save money on the tickets. If you went 3 times, it's not going to be exactly 3 times that, but it starts to become, I'm pretty sure we could have gone to the beach for a week, right? It can be very expensive making multiple trips. So I kept trying to tell the kids, you know, it's not as cheap as just buying those 5 tickets. There's all these other things that go into it. Just a fun little reminiscing of Busch Gardens. All right, so that finishes up real life algebra. Let me point out the 2. These were silly little things I think I found in your book, and you can look at the answer key. Why anyone would do it like that, I'm not sure, but this is a nice review of how to figure out what a plus b squared is and a minus b squared. So definitely do number 5 and 6 on real life algebra and look at the answer key. Maybe I should make one comment on that. While I would never do the technique that they want you to do there, I do absolutely need you to know. Well, first let me write what that is not. Do you want to know the most common mistake not only Algebra 1 students, high school students, and college students make? So you see that's a not equal, right? They do that. That is not what that equals. This is a plus b So you've got a squared plus 2ab plus b squared. That's what it expands to, right? And then a minus b squared is a squared minus 2ab plus b squared. So I do expect that you know that. All right, so that's it for real life algebra. Let's just go on to some other review problems. Again, you can pause the video and try these 9 problems, then come back. Some of them are similar to the miscellaneous problems we did on the last video. All right, write an equation for a line parallel to. So remember what we talked about. You have no idea what the slope is until you get it in slope-intercept form. So minus 42y equals 163 minus 20x. Got to divide by minus 42 to every single piece, right? This is going to be plus. Let's go ahead and reduce that. 2 goes into 20 10 times. 2 goes into 42 21 times. So that's 10 over 21x. This is your slope. We need something parallel, so it's going to be the same slope, right? Oh, and this problem did not say through a particular point. So our parallel line, then we can just use whatever intercept we want, except for that awkward number. Any number you want there. I don't care what number, infinite answers, except for that. You just can't use that number, but you can use any other number you want. All right. Oh, number 2 seems a bit tricky. When something seems tricky, draw a picture. Find an equation of a line. So it has to go through 3, 4, and it has to be perpendicular to the x-axis. So it's not like they gave me a linear line and I could change the sign and do the flip-flop. So this one seems confusing, so hold on. You got to make sure you know what the x-axis is, right? This is the x-axis. I want to be perpendicular to that. Well, why don't we go ahead and put the point 3, 4 on there? I don't know, 1, 2, 3. How about that? We'll call him 3, 4. Perpendicular. There's a picture, right, of a line perpendicular to the x-axis that goes through 3, 4. Oh, of course, because the x-axis is horizontal. Then what is perpendicular? Vertical. So we need a vertical line. That was part of those, I think, the first day notes for reviewing algebra. Vertical lines are the form x equals what? X equals 3. All right, let's practice solving a system of equations. Let me write it how it was originally. So first of all, catch that it is all a mess. Nothing is lining up. It all just looks very, very messy. I'm not liking that I have these 1.5s, right? They're decimals. It could have been 3/2, fractions. It's much nicer if we get to whole numbers. So let me rewrite my first one. Let's multiply everything by 2. So I've got negative 3x. Well, that's going to confuse you if I do that. Negative 3x minus 3. I'm multiplying by 2, right? By 2 equals negative 6y. Now, I really do need to line some things up. How about, I mean, he's pretty nice. How about if I send this over here and I send this that way? right, so my negative 3x is going to stay. Negative 6y, I'm bringing him over here, so that's going to be positive 6y. My negative 3, I'm sending him that way, so it's going to be 3 over there. And yes, as I rewrote things, I lined up my variables. It just makes it much nicer. Oh, this is begging for elimination method, right? I hadn't even looked at my notes I prepared. This is begging to be added because 3x plus negative 3x, my x's are going to go away. 8y, 3 plus negative 3 is 0. 9 plus 3 is 12. So y is 12/8 or 1.5. Put him in wherever you want and you'll end up with 2. If you want to write it as a coordinate point, it's 2, 1.5. All right, number 4 is back to, in this case, it's growth, just like all of our tax problems. Or I think, again, there may have been a recycling problem or something. A utility company expects electricity to increase 8% per year. Increase 8% per year for the next 3 years. At the end, what increase is that? All right, so first year. Now, ideally, at this point, you know you can write it as 1.08x because we've done lots of these problems. Like for tax, I would write it as 1.05x, but I'll back up to square one. Increase, 8% increase. X plus 8% of x. Remember, there's a 1 sitting here, right? So 1 plus 0.08 is 1.08x. So that's how much at the end of the first year. Let's do the second year. Well, it's another 8% increase, but increase of what? This is the base now, right? So that's how much I have. I have to increase 8% of that. And I know when we're in the classroom, I get a lot of questions on this. And one thing that sometimes is helpful, if you kind of put your base in a little bubble. So you've got the bubble plus 8% of the bubble. So you can make sure that you wrote everything enough. Well, I've got one bubble plus 0.08 bubble. Let me grab a different color. Where's my green? So, you know, there's 1 here, right? One of these bubbles plus 0.08 of these bubbles is 1.08 of the bubble. Oh, well, I'm already feeling like there might be a pattern here. This is 1.08 squared x. If you really want to know what the number is, it's 1.1664x. So I'm just trying to show it in quite a few different ways. Let's keep going, because after a couple more, you really will see the pattern. Okay, we're going to grow 8% again. Of what? Of this guy now, right? Or if you want, you could view this as the bubble. I've got that plus 8% of that. See, that's my little bubble. I got my bubble plus 8% of the bubble, which is, I got one of the bubbles plus 0.08 of the bubbles. So I have 1.08 of the bubbles. Oh, this is so weird. Look, it's 1.08 cubed times x. Now, if you're not liking seeing the pattern, let me sort of split this for a second. We knew that was the end of the second year. So 1.1664x plus 0.08 of 1.1664x will still give you 1.2597. So right now I've just tried to present it. This probably is the clearest, although you lose the pattern. And I really wanted you to start to see this pattern because we can now easily look. The second year, I squared it. The third year, I cubed it. I can quickly put up the fourth year. It's going to be 1.08 to the fourth x, which is 1.3605x, right? This is how compounding interest works. Fourth year is 1.36x. I'm shortening it up so I can talk about it. Basically, remember up here we knew that 8% growth, that's 108% because that's 8% growth. When you see 1.36, then you know it was 36% growth. When you hear that you're going to get 8% per year, a lot of people might think, oh, for 4 years, that's 8 times 4, 32% growth. No, it's not. It's more than that. If you've ever heard the saying, you make interest on interest, or that idea of compounding interest, that's why you should start to save money when you're young, because it starts to accumulate so much quicker because you end up making money, interest on interest, not just on your principal. So this was not just a problem to be difficult to you and to confuse you. This is exactly how savings, stock market, money market accounts work. You want to make interest on interest and you want it to be able to grow for a while. And that's why all the financial calculators are programmed into the internet, but they're always to powers. So this type of problem right here, where you're growing the same amount year after year, is extremely real life. And hopefully savings and having your money grow will be real life for you. All right. Now granted, that was slightly tricky, especially because we went up to 4 years. All right. Oh, I stole this from one of my colleagues, but I've given a few extra little hints on it. The cupcake company is available for catering. The cost of catering can be described with a linear relationship. So they're telling you, let me put my board back, sorry, that there's a linear line involved. All catering jobs have initial cost of $20. But if you order 12 cupcakes, the total cost would be $29. And I've helped you out here because I didn't think this question was very clear. X is the number of cupcakes, and Y is how much is it costing me. So I was fine with hey, I ordered 12 cupcakes, it cost me $29. I'm going to be honest, the first time I read this, I missed the obvious. All catering jobs have an initial cost of $20, meaning even if I order, or for example, if I order 0 cupcakes, I'm paying a minimum of $20. Apparently, if I order 12 cupcakes, I'm going to pay $29. So those are the 2 points involved, and they said it was a linear line, so we just have to make sure we calculate slope now. Slope, now I already have it set up vertical, so 29 minus 20, 12 minus 0 is, do the math, negative, that's silly, 0.75. First time I did this, I ended up making this problem longer than it needed to be. This is the y-intercept, right? I don't have to plug this in to solve for b. My b is 20 because a y-intercept where x is 0, that's the y-intercept. So I'm done. 0.75x plus 20. That is the equation of the line. So apparently every cupcake costs 75 cents. That's what that slope is telling you. There's an initial cost of $20, and then every cupcake is 75 cents. All right, let's do 6. Oh, these were, oh, no, sorry. 6 is, I don't know if you've ever seen I want to call them stupid, I should call them silly, Facebook posts where little magicians trying to trick you or impress you with their skills or something. So, this is the way one of it, he was on my Facebook and, he's like looking into the camera, making it seem like he's talking to me. He says, think of your age. Now add 3. Now subtract 5. Now add 7. And he says, lock this number into your head. Now he wants you to subtract your age from that number. Then add 5, multiply by 2, and then add 1. And then lo and behold, he's going to be able to guess your number. And of course your number's 21. And you're supposed to be fascinated because everyone would be a different age. How can you go through all those steps and everybody ends up with 21? So we want to prove how that's the case. All right, so we're going to let X be your age. All right, so you're supposed to think of your age. Now you're supposed to add 3. Then you're supposed to subtract 5. Then add 7. And then he takes the drama to say, lock that number into your head. Okay, well, 3 minus 5 plus 7, minus 2 plus 7. This turns out to be X plus 5, right? So lock that into your head, X plus 5. All right, then he says, lock this into your head. Okay, that's locked into my head. Now I'm going to subtract my age, then add 5. I'll get to the multiply by 2 in a minute. Oh, well, the x's cancel. So now I'm at 10. Then he says multiply by 2 and add 1. And lo and behold, no matter what your age was, this always works. And yes, the answer is 21. Okay. All right, 7. We're back to simple solving algebra, but I know sometimes you guys forget the nice little tricks you can do if you want to get rid of fractions. So I don't like looking at the 6/7, but here's the issue, right? Why don't we at least add 2 to both sides before I deal with what I don't like? Okay. Now, many of you want to say divided by 6/7, which is completely correct. And as long as you know how to divide by a fraction, you're perfectly fine. I just want to present the exact same concept in a slightly different way. How about if we times both sides by 7/6? That goes away. The 6's go away. So y equals -7. Okay, number 8, solve. Okay. This one really has a ton of yucky fractions in it. I hate seeing 12s and 3s. Why don't we just multiply everything by 12? Times 12. So that's going to be 5x. Times 12. Times 12. 12 times a third. I am expecting that you know that 12 times a third is 4. Times 12. Times 12. That's a whole lot nicer to look at than the original, right? And now we can just start cleaning it up. Let's add 48 to both sides. Might as well put those two together. 48 plus 72 is 120. Let's subtract 12x. So I've got -3x equals 120, or x equals -40. stick him, oh no, I'm sorry, there's not a y here, it's just x. Okay, one more quick problem because I'm afraid my computer is running out of memory. Oh, this one was to make sure you understood the language. When it says subtract that from that, this is the guy that comes first. So this was all making sure you knew what the word of, the meaning of the from. I'm subtracting this from that. So it's that order. Make sure you distribute your negative. Negative 5x squared plus 9x minus 7 minus 3x squared plus 4x plus 13. This is just a simplified problem. It's not a solve. There is no equal sign. That gives you negative 8 squared. Like grouping my like terms, right? That is 13x. And I guess that's 6. I must have stolen this from the book. All right, so at this point, I'm done with all material. You guys need to start sending me questions as to what you're confused on or that type of thing that we can go back over either through WebEx or emails or whatever. Talk to you soon.